Every language in the world has its own word for snow, and it can be mesmerising to watch snow falling from the sky and changing the landscape round about you. Snow can also feel magical, which will be why it's been a main feature of such fantasy books as The Lion, the Witch and the Wardrobe and The Snow Queen, the latter of which was the inspiration for Disney's Frozen. But behind this natural beauty is some fascinating science, and now we're at the time of year where people will be dreaming of a white Christmas. So, with that in mind, here are 10 things you should know about snow. 1. It doesn't need to be freezing for you to get snow. Usually the air temperature needs to be around the freezing point for snow to be able to form. However, if it rains for long enough, it can lower the air temperature and lead to the formation of snow. For every 1,000 metres up into the sky you go, the temperature drops by around 7 degrees Celsius. This means it could be 6 degrees Celsius down on the ground, but still snowing due to the freezing temperatures up above. Although you can get snow falling in temperatures up to 6 degrees Celsius, there is a point where it is too hot for snow to be able to fall. Technically, it can never be too cold for snow to fall due to temperature alone. However, temperature does have a complex relationship with humidity and cloud formations, which does mean in some parts of the world it is unlikely to snow below a certain temperature. 2. There needs to be pollen or dust in the air to form snow. The first step in the formation of a snowflake is an extremely cold water droplet freezing onto a single particle of dust or pollen in the sky. If the temperature is at or below freezing point, which is 0 degrees Celsius, then an ice crystal will form around this tiny particle. As it descends from the sky, water vapour will freeze onto that initial ice crystal, and that builds new ice crystals, the 6 sides of a snowflake. The fact that snowflakes form around a single particle makes them different from sleet, which is frozen raindrops, and hail, which is sleet droplets that have collected water as they've descended. 3. Every snowflake is unique. With snowflakes, similarity depends on how closely you look. Some of the factors which affect the appearance of snowflakes are the conditions around it. Every snowflake makes its own individual journey from the sky to the ground, so they all encounter different atmospheric conditions as they descend. If you look closely at snowflakes, you will see countless individual features, all having formed slightly differently in shape or size due to the different atmospheric conditions each snowflake has encountered as it's descended. The study of snowflakes has shown that thin needle-like snowflakes form in temperatures around -2 degrees Celsius and flat plate-like snowflakes form in temperatures around -5 degrees Celsius. To think of the number of possible ways that a snowflake can form, let's use the analogy of trying to arrange 15 books on a bookshelf. You have 15 choices for which book goes in position number 1, 14 choices for number 2, 13 choices for number 3, and so on. If you multiply together all the possible ways that you can arrange these books on the shelf, there are 1 trillion different ways that these books can be organised. Now think of all the countless different nuances in temperature and humidity that a snowflake can encounter as it falls from the sky, and that is why every single snowflake is unique. 4. Although unique, there appears to be a set number of types of snowflakes. There have been many attempts to examine and classify types of snowflakes, starting in 1951 with the International Commission on Snow and Ice deciding on 7 types. Later on, physicists and meteorologists decided this wasn't complicated enough and came up with 41 types and then 80 types of snowflakes. In the book Field Guide to Snowflakes by physicist Kenneth Libbrecht, there are details of 35 types of snowflakes. This is a very practical guide to snowflakes and is excellent for young science and weather loving readers. So although every snowflake is unique, there appears to be a set number of types that a snowflake can fall into. 5. The largest snowflake may have been 15 inches across. Although there is no evidence to back up this claim, made regarding a snowstorm in Montana, America in 1887, scientists have said there is nothing to actually stop snowflakes reaching that size. For years there have been many reports of giant snowflakes ranging in size from 2 to 6 inches. However, the size of snowflakes is not a way that meteorologists measure snow. It is also very possible that these giant snowflakes are out there somewhere but get broken up by the wind or other environmental factors before they make it to the ground for somebody to be able to measure them. 6. Snow falls at speeds between 1 and 4 miles per hour. The speed that snowflakes fall at is affected by their mass, surface area and environmental factors. Wind speed and snowflakes gathering water can increase the speed of their descent up to a reported 9 miles per hour. The majority of the snowflakes we encounter fall at around 1.5 miles per hour, taking about 1 hour to reach the ground. On the topic of speed, there are certain strict rules about what can be classified as a blizzard. To start with, the wind speed must be at least 35 miles per hour. Visibility due to falling or blowing snow must reduce to below 200 metres, and also this must last for at least 3 hours before it can be classified as a blizzard. 7. Snow is not actually white. Light is a spectrum of colours, and the colours we see are being reflected back at us while other colours are being absorbed. For example, with the red petals on a flower, red light is being reflected back at us while the other colours are being absorbed. Snowflakes are translucent, which means light does not easily pass through it. Instead, what happens is the light gets scattered around inside the snowflake, which diffuses the colour spectrum, reflecting back out to us as white. Snow sometimes though can appear as different colours as a result of pollution, dust or even freshwater algae. This can lead to snow looking black, orange or even pink. The deeper down in snow that you look, the bluer the snow is going to appear. This is because red light gets trapped higher up in the snow, and that is why the bottom part of glaciers can often look blue, because that red light has been trapped and the blue light is being reflected back out. 8. Igloos can be 100 degrees warmer inside than outside. Despite what you might think, snow has excellent insulation properties, being made up of 90 to 95% trapped air. Because this air is trapped inside the snowflake, it doesn't have much room to move around, and that means that heat gets trapped inside. That is why there are animals that will burrow into the snow to keep warm, and why igloos are warmer inside than outside. Igloos are warmed by body heat and warm air rises. Igloos tend to be split up into 3 layers, with the top layer being where people sleep because that warm air rises, so that is the warmest level, and the bottom level has very little activity other than people entering and leaving, so it is the coldest area, and this also stops cold air being able to blow in from outside, and that is why igloos can be 100 degrees warmer inside than outside. 9. Snow can affect sound waves. Freshly fallen snow absorbs sound waves, and this makes everything seem quieter. However, when this snow melts and is refrozen, the ice then reflects the sound waves, making the sound clearer and able to travel further. On the topic of sound, there is a common myth often shown in film and televisions that noise can trigger an avalanche. There are many things which could trigger an avalanche, such as increased weight in the snow, a sudden snow dump, wind speed and even people's footsteps on the snow. However, loud noises is not considered a trigger for an avalanche. 10. There's a possibility that there is snow on Mars. Simulations run by NASA based on the atmosphere of Mars show that summer in the north of the planet could bring snow. It is already known that there is polar ice on Mars, and while these simulations right now only remain a possibility, they do match up with some observations made by one of the Mars robots in 2008. Carbon dioxide snowflakes have also been detected in the south of the planet. While there is still more study and observation to be done in this area, the current research looks fascinating. There are 2 things to keep in mind at the end of this video. 1. From the intricate patterns of snowflakes to the way it changes our landscape. From needing to be cold to form to being able to keep people warm, and from the way it absorbs sound to the way it scatters light, snow is an incredible and beautiful part of our natural world. Even monkeys like the snow, with Japanese macaques being nicknamed snow monkeys, having been observed playing with snowballs. And 2, although we know a lot about snow here on Earth, as we expand our horizons to our solar system and the rest of the universe, there are lots of other places where freezing conditions and snowflakes might exist. Places such as Enceladus and Europa, which we know are covered in ice, but we haven't been able to examine if there are snowflakes there, and there are other places yet to be discovered. What more can we learn about snowflakes here on Earth or even on other places in the solar system? What might we discover on places like Enceladus and Europa, and could we discover life there? These questions remain to be answered. Thank you for watching this Things You Should Know video, and I've put a link in the description to a STEM activity I did where I examined crystallised snowflakes. If you enjoyed this video, please hit the like and subscribe buttons to stay up to date on all future content. The information for this video was drawn from various sources across the internet, so I'll put links in the description for you to check them out. I also took some information from the Field Guide to Snowflakes by physicist Kenneth Libbrecht that I mentioned in the video. You can subscribe to the channel by pushing the button here, and I've added links here to the STEM demonstration and explanation videos that I do, as well as down at the bottom to my STEM career interviews and to my other Things You Should Know videos. This has been STEM with Mr. N with 10 things you should know about snow.